everyone. In this video we're going to be continuing talking about functions, which we've been talking about a lot lately, and we've done these previous objectives in other videos, and this one we're going to focus on this objective right here, where we're going to find the difference quotient of a function. So this is the definition that we call the difference quotient. So difference, just think subtraction, quotient for division, so it's this division involving these terms on top that are getting subtracted. And so it's f of x plus h minus f of x all over h, where h can't be 0 because we don't want to divide by 0 because that would be undefined. Alright, just a little bit of background for you here, why we're learning this, and then we'll get right into some examples. Let me show you that you actually kind of know what this is talking about. I know it might look like a whole bunch of like math symbols, but let me make it make some sense to you. Okay, think about the top. Okay, you have f of something minus f of something. Those are y values. So this is a y value. This is another y value. And I'm going to call this one y1, and I'll just call this one y2. Now on bottom it's just h, but what we could also say is, watch this, we could say that the bottom is the same thing as x plus h minus x. Okay, notice if you subtract those, you will just be left with h. And so this is an x value, we'll call this x1. This is another x value, we'll call this x2. And so take a look at what you have here. On top, you have a y minus another y. On bottom, you have an x minus another x. This should look familiar, I hope. This is your slope formula. So this is giving us, at this point, an average rate of change of our function. In the future, you're going to do something, if you continue to calculus, called the derivative of a function, and you're going to take the same expression and you're going to set this h to be very, very small, like approaching 0, and then that's going to give you what's called the instantaneous rate of change. So this is just going to represent the average rate of change or slope of our function. And just another quick note, this plus h part is just saying like the x value you started with, like this x here, just plus a little bit more. So that same x, just plus a little more. Like, okay, so that was some background for us. We're going to go right into an example here. So find the difference quotient for each function. Notice you're just given the function. And so in order to find the difference quotient, I have to know what it is. So I have to know that this is what's really being asked of me. I want to find this quotient, this expression. I want to know what this equals. Okay, but I have to use my specific function that I'm given. So I'm going to be plugging some stuff in. Alright, so notice exactly what got plugged in. F of x, let me just sort of highlight some things so it makes sense to you. F of x is the original what's given. So in this difference quotient, right after the minus sign, you're always just going to plug in your original function because it's minus f of x. So that's what you're given, that's this part. And so you're just going to plug this in right there after the minus sign. So that's x squared minus 1. Okay, so that just gets plugged in right after that minus sign. So you have your minus sign, right after that, plug in what you're told. Now, this f of x plus h part, that one you got to do a little bit of work, and then you end up simplifying. And the little bit of work is where there was an x in your original function, exactly in that place, you're now evaluating your function at not just x, but x plus h. So let me write that down, because if you can get this part, then you're going to be good to go on these difference quotient problems. So normally, and I'm going to do some erasing, normally the function was f of x equals x squared minus 1. Okay, so what I'm going to do, and every time I'm evaluating a function, is I'm going to put parentheses right around x, and I'm going to erase x. And so for this particular one, we're told to plug in x plus h. Okay, so I'm asked, it's not explicitly saying, hey, put an x plus h where there used to be an x, but because we're asked to find the difference quotient, that's what needs to be done. So exactly where there used to be just an x, you're going to erase that x and put an x plus h, exactly in that same spot. So it goes right where that x used to be. And so notice that's what we have right here. That's this thing. Okay. So that's one of the trickiest parts that I see that people get stuck on. So if you can get this part, then the rest is simplifying. Okay, so we'll do more examples to help you on that part. But after that, we're just simplifying. Okay, so notice what you have to do. You actually have to FOIL. So x plus h, I'll do it off to the side. Quantity squared is x plus h times itself. So you want to FOIL this out. So x times x is this x squared right here. And then you have x times h, so that's 1xh. And then h times x, that's another xh. So that's this part, 2xh. And then last times last is h squared, this part here. Okay, so that's from FOILing, when you have your binomial. And then you still have the -1. And then notice back here, you're going to distribute minus, so minus x squared, and minus a -1. That's why this became a plus right here. Okay, and then after you've done that, that was one of the harder parts too. The rest is simplifying. Combine any like terms. I'm going to go ahead and show you what terms combined. We'll go ahead and use purple. X squared minus x squared added up to 0. -1 plus 1 added up to 0. And so this is all that we're left with. And you can hopefully see that this simplifies a little further. There's h's in all of your terms, in both the terms on top and also on bottom. So you're going to factor out an h, and then because you're multiplying right here, you are allowed to divide this out. So divide h by h, and then that is going to give us our final answer. So we have 2x plus h. All right, let's try this one. So same directions, find the difference quotient. Okay, exactly where there was an f of x plus h, we are replacing the x with an x plus h, and then exactly where there used to be just f of x, we're plugging in our function. So right here, after the minus sign, right after the minus sign, we just plug in our function. So that's why there's a 1 minus x after our minus sign. And then our function, if we plug in an x plus h, is just 1 over x plus h in the front before the minus sign. And then now, so that's one of the harder parts. Now we're just simplifying. Okay, so we're on to the simplification step. These are fractions, and they're pretty messy, like a fraction over a fraction. So we're going to have a common denominator, so we can combine these. So let's go ahead and do that really quick. So the common denominator would be x plus h times x. So this fraction here, if you remember working with fractions, common denominator needs to be multiplied by x plus h, top and bottom. This one here needs to be multiplied by x, top and bottom. Okay, and then that's where this comes from on the top here, x minus x plus h, when you just multiply both of those by 1. And then on bottom, you have your LCD, your common denominator, and then you still have your very bottom of the fraction h. Okay, and now you don't ever have to leave fractions in fractions like this, how this looks. So what we're going to do is we're going to flip and multiply. This is h, but that's technically h over 1. So if we flip and multiply, that becomes 1 over h. So when we flip this over and multiply, and that's where this extra h came from. It's from flipping and multiplying. Okay, so just working out our fractions. And then simplify if we can. And notice that the x minus x goes to 0. And then we have a negative h on top. We're multiplying by an h on bottom. So we can divide those out, because that's going to be negative 1 left over on top. And so go ahead and bring the minus to the front. And then this is our final answer. Okay, so negative 1 over x times x plus h. All right, let's take a look at the one more example. So finding the difference quotient of 2 times square root x. Okay, so exactly where we had an f of x, we just plug into square root x in the back over here. And then in the front, same function, but where there's an x, put an x plus h. Okay, and then simplify if you can, And on this one's a little tricky on the simplification, but what you do on these types of expressions is you multiply by the conjugate of the one with the radical. In this case, it's the numerator. So normally when we see an expression with a fraction, so this quotient, and part of this has radicals, we multiply by the conjugate, which means we just change the sign. So notice it's a plus sign, and then you do the same thing top and bottom. Okay? And so what you're going to end up having here, and be careful here, there's a step that's skipped, but I'm going to work it out for you. You actually still have to FOIL out this part here. So this is going to require foiling. It doesn't quite look like it from the next step, but it is. So watch this. So we're going to FOIL, so we're going to say first times first. That's this part here. 2 times square root of x plus h, quantity squared. And then outer times outer is going to be 2 times square root x plus h times 2x square root x. And then inner times inner is negative 2 square root x times 2 square root x plus h. And so notice what happened there. These two, when you combine them, they add up to 0. Okay, so that's why they're not written. And then last times last, negative 2 square root x times positive 2 square root x is this part right here. So it looks like you might not have had to FOIL, but you actually had to. And then the two terms in the middle add up to 0. And then on bottom, you just distribute. So you say h times this quantity and this one here as well. Okay, and then if we start multiplying out what we can, 2 squared is the 4 here. You squared away this square root on this one, so the squared away with this square root. And then in the back, similar thing, the 2 got squared to make 4. You squared away the square root. And then on bottom, we still could distribute if we wanted to, or we can leave that h out front. And we're going to leave it out because when you combine like terms, you end up with 4x plus 4h minus 4x, and all you're left with is 4h. And then those h's, one on top and one on bottom, because you're multiplying, are going to cancel out or divide out. And then this is what we're left with for our expression. So final answer. Okay, so this was just a quick video on practicing finding the difference quotient for some different functions. Thanks for watching.